Okay, so to illustrate this idea of the sampling distribution and the mean of the sampling distribution and the standard error of the means, I'd like to do a simple demonstration with a dice. Okay, so a normal six-sided dice has six numbers, obviously. 1, 2, 3, 4, 5, and 6. So imagine that this was the true, this is our population. So if we rolled the dice an infinite number of times, what would be the mean of the population? So what mean would we expect given this distribution of 1, 2, 3, 4, 5, and 6? Well, what's the probability of rolling a 1? It's 1 out of 6. That's sloppy. 1 out of 6. What's the probability of rolling a 2? It's 1 out of 6. 3, 1 out of 6. You basically have a 1/6 chance to roll a certain number every time, okay? So if these have equal probabilities of rolls, then we would expect an infinite number. We'd have equal numbers of each. So how would we get the population mean? You just add 1, 2, 3, 4, 5, and 6, which is 21, right? 10, 21, divided by 6, which is 18 and a half, which is 6. Sorry. Holding the camera over my work is interesting. Sorry about that. So we added these up, we get 21 with a sample of 6, right? So divide 21 by 6 and you get 3 and a half, right? Do it on the calculator if you don't take my word for it. 3 and a half, okay? So 3.5 is our population mean. Okay, so now let's imagine that we roll the dice. So let's make our little plot here with a 1, 2, 3, 4, 5, and 6. Okay. So let's say we want to take samples of size 3. And I'm going to do that, let's do 10 times. So I know this is a little tedious, but bear with me. So basically what I'm trying to illustrate here is we're taking samples of size n equal 3, right? Samples of size 3, and we're going to do that m times 10, okay? And then we're going to plot our sample means in a sampling distribution of the means, okay? Let's roll the dice. Okay, so let's be specific here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's our 10 samples. So on the first row we get a 6, a 1, and another 6. Okay, so what is the mean of this sample? Well, 6 and 6 is 12, plus 1 is 13. So you have 13 over 3, which is equal to 4.3. Right? Yep. Again, if you don't take my word for it, you can do it on your calculator. 4.3. So let's plot our first sample mean right here, 4.3. We plotted a rate of 4.3, okay? So sample 2, and we get a 3, and we get a 2, and we get another 3. 3, 3, 2, okay? So 3 and 3 is 6, plus 2 is 8, 8 over 3, and we get 2.6. I'm gonna cross this out just so not distracting us. So see how we've taken 2 samples here and gotten 2 different means. I'm gonna plot the second one here. 2.6. Okay. Sample 3, we get a 6, a 6, and a 1. So that's the exact same one as we got on the first one, so get another 4.3. So I'm going to draw another 4.3 there, okay? Sample 4, we get a 6, a 2, and another 6. Rolling high today. Okay, 14 over 3. So that's 4.6. Plot that little guy right there. Okay. Sample 5. A 4, a 1, and a 6. 4, 1, 6. So that's 11 divided by 3 is going to give us 3.6. Okay. Sample 6. 1, 2, 5. So it's 8 divided by 3 is going to give us 2.6 again. Okay. Sample number 7. 4, 4, 5. 4, 4, 5. Okay, so 4 and 4 is 8, plus 5 is 13. We've already done 13 over 3, and that's going to be 4.3. Okay, so there's another 4.3 for us. Sample number 8. A 4, a 5, and a 1. So that's 10 divided by 3. It's going to give 3.3. Okay, sample number 9. So I'm running out of space. I'm going to put those over on this side. 3, 4, 5. And that's 12 over 3. That one's easy, so we get a mean of 4. Right? 3, 4, and 5. Add them up. You get 12 divided by 3. You get 4. Okay? So let's plot that mean right here. Okay, and then the last sample, sample 10. A 6, a 4, a 5. Sample 10, we get a 6, 4, and 5 is 15. Divided by 3 is 5. Right on the nose. Okay. So here's our sampling distribution of the means. So see how I've plotted 10 different means here. Okay? And so again, this is a hypothetical example. Typically, we don't know the true population parameter, but in this case, we do. Remember, it's 3.5. Okay? So if 3.5 is right about here, yeah, it's not absolutely normal, but I bet if we continue to take these, in fact, I don't bet, I'm positive, they would line up, kind of in a normal fashion there. But let's go back to what I talked about earlier, the mean of the sampling distribution. So this value, the mean of the sampling distribution, aka the mean of means. If we add up all 10 of our means, we get 4.3, 2.6, 4.3. I'm gonna have to do this on the calculator. Bear with me just a sec. Pull up my calculator. Okay, so basically I'm gonna take all these means, 4.3, 2.6, 4.3, 4.6, 3.6, et cetera, and add them up and divide by 10. That'll be the mean of means, correct? Okay, so let's go to the calculator here, and so 4.3, right, 4.3